Good morning. Now we are going to see about introduction to phase equilibria. In this, we will discuss about the concepts of phase, component and degree of freedom with example. Phase rule states that for a heterogeneous system in equilibrium, the number of degrees of freedom is related to the number of components and the number of phases by the equation, known as F is equal to C minus P plus 2, where F is number of degrees of freedom, C is number of component, P is number of phases. A phase is a homogeneous part of a system which is separated from the other parts by definite boundaries. For example, we can see ice cube which will exist in solid state, which is in equilibrium with water in liquid state and also in water vapor in gaseous state. So at freezing point, water consists of 3 phases, and then completely miscible liquids such as water and alcohol constitute only one phase, and it comes under one phase system. Now consider the decomposition of calcium carbonate into calcium oxide and carbon dioxide. It exists in only one phase, that is solid phase. Now we will define components. The chemical species that form a system are called constituent of a particular system. For example, an aqueous solution of sodium chloride has two constituents, that is sodium chloride and water. The constituents whose concentration of each phase of a system are called components. So the components of a system may be defined as the minimum number of chemical species sufficient to determine the composition of each phase of a system. Example for components: the water consists of 3 phases, which we already discussed. It is a one component system and each phase is represented by the same chemical species known as H2O. An aqueous solution of potassium chloride, that is KCl, is a one phase, two component system, that is KCl solution consists of KCl in solid state with water. Then we will discuss about degrees of freedom. The minimum number of independently variable factors such as temperature, pressure and concentration that must be specified in order to define the system completely. Example, a pure gas obeys the ideal gas equation PV is equal to nRT. If any two out of 3 variables, pressure, volume and temperature, are specified, the third variable is fixed automatically. Hence, we require two variables, that is pressure and temperature or pressure and volume or volume and temperature, in order to define the system completely. Hence, a system consisting of only one phase is a bivariant system. P equal to 1, C equal to 1. F is equal to C minus P plus 2. If we substitute P value and C value, 1 minus 1 plus 2, which leads to 2. So it is bivariant system. A gaseous mixture of H2 and helium is a single phase, two component system. Hence it has 3 degrees of freedom, that is P is equal to 1, C is equal to 2. If we substitute this value in phase rule, F is equal to C minus P plus 2, 2 minus 1 plus 2, it will be 3. Thank you.